Hello world, and welcome to the final episode of the Dependency Injection series. As promised, today we're going to get hands-on with dependency injection, taking a super simple application that has no dependency injection setup, and we will refactor it live, and hopefully, by the end of it, we will have implemented a version of what is known as pure dependency injection, or poor man's dependency injection. As I have stated before, I do not like the latter term as it carries a negative meaning to convey a rather positive and good practice. Pure dependency injection is the separation of the functional and compositional set of classes, but without the use of any framework. I'm not saying that frameworks are bad. On the contrary, they're a great help. I'm just saying, however, that it's absolutely fine if one wants to live without them. Also, not utilizing any framework will help in us better understanding the underlying concepts. So, without further ado, let's first see the application. It's super simple as any app can be really, but it's set up using Model View Presenter as the presentational layer design pattern, so the basis is good. So we have a simple button that we can click, then a loader appears for a couple of seconds, and finally, we see a toast message that prints some strings. This represents a basic action that the user clicks a button, something takes place on the background, and that action produces a response that the user views as a UI update. So now, let's dive into the code. Okay, here we are. So, in our application, we have our main activity that implements the view interface from our main contract. Our contract, which we usually use in Model View Presenter, consists of two interfaces, the view interface and the presenter interface. This simply acts as a public API for the view. For example, we can show a loader, we can hide the loader, and then we can also show the success in our very simple application. And the presenter simply gets notified when the button is clicked. So that's pretty simple. In our main activity, we are creating the presenter currently from the inside. So we already know that this is something that we should inject back from video number 3. So we'll have to keep that in mind. And let's see the presenter. The presenter creates the interactor inside. And finally, and this should also be injected by the way, and finally the interactor gets a looper as an argument. Now, this is an overkill. This would never happen in real time. Usually here we would have, for example, a retrofit API implementation. But since I wouldn't want to involve retrofit and network in this very simple application, I just use the looper to mark as an external dependency of our sample interactor. So as we have already seen, we need to create a composition root, a place where we will create our objects. But where should this composition root be created? As we have said, this should be the main of our application. And where is the main entrance point of an Android application? This is the application class. Now, every application in Android has an application class, but it's implicitly created by the system. So if you want to override it, so we can use it to add some stuff, which every application usually needs, we have to create it ourselves. So let's create a new file and call it our application, my application. Perfect. And our application class will need to have, of course, should extend application. Perfect. In order for this to apply in our application, we need to go to the manifest and set it up as the name of the application. So now our whole application goes through our custom my application file that we just created. And here we're going to create our composition root. So let's do that. My composition root. And this is of type composition root. We have not yet created that. So let's create that. create class composition root. Yeah, thank you very much. I want to extract in a separate file. So now when we go back to my application class, we can safely create our composition root. So, of course, we can use our application as a composition root, but that would get messy since we're going to add a bunch of code later inside here. So it's much better off to just create a separate class to use for that. So our composition root is the place where we are going to create our objects. So let's take it from the start. Which are the objects that need to be created here? Let's go inside my activity and see the references. Let's see the dependencies. So my presenter, oh yeah, this is the usual suspect. This really needs to be created from the outside, a main presenter implementation. So let's go back to the composition root and create a method that's called get main presenter. So this returns a main presenter. Of course, this should return the interface, not the concrete implementation, but inside here, we are going to create an actual use of the presenter. So return main presenter implementation. All right, this looks good, but the presenter implementation takes an argument. And what is that? The view. All right, so we're going to pass it inside that method, and that view is a main activity. It's actually a main view. So passing that view in the main presenter implementation gets rid of all the compiler errors. So this looks pretty good. Let's go back to the activity. Here we go. And of course, we have to create this presenter as a later init var and use it in a different way. Now we need to delete all that and take the presenter, and inside here we have to do the following. Get the application. As my application, we have to downcast it since we have created our own instance of the application class. And then from here, we can get access to the composition root and then get main presenter passing ourselves as the main view. So this works. Now, probably you don't like that. Probably this syntax seems too long, and it's actually the opposite of getting from the outside. We are still referencing and we're still requesting to get the presenter. But don't worry, I'm going to show you a quick syntax trick to ease that ugly syntax here. So moving on, getting inside the presenter, we have the interactor reference. All right, this needs to be injected as well. So let's take it in the constructor. We could not use the constructor in our activity due to the way Android works, but here, this is a class we have created and we can pretty much use our constructor. So this is what we're gonna do. Passing my interactor. Of course, this class is with the interactor that was already there, but don't worry about that. Get rid of the looper for now, optimize imports, and then go back to where we created that. And this needs a presenter. So this needs an interactor. So let's create another class called get sample interactor. And that returns a sample interactor. And inside, we're going to return my sample interactor. Okay, first of all, let's use that and pass it here. So this looks good. Get main presenter is green again, but we have a red error here. What does that need? It needs a looper. Alrighty then, we're going to create another method that's called get looper. As I said, this is totally overkill, but for the sake of argument, we are going to create it. So looper, get main looper, and everything looks good. So let's get the get looper method, pass it inside the my sample interactor. Of course, this could be private. and this could be private too. This should not be private yet because we reference it in my activity, but as I said, we're gonna get back to that and fix it. For now, let's keep it public. So, if I'm not mistaken, we have eliminated every place that we created object from the inside. My presenter implementation gets everything from its constructor, so everything is injected properly, and then my sample interactor also gets a looper. We are not injecting this list because this is a data structure, and as we said in episode 2, data structures should not be injected, but they should be encapsulated instead. But what should we do about that ugly syntax right here? Well, if you've seen some frameworks before, they usually do something like that. They go like inject, they pass themselves inside, and this actually takes care of all the injections. So we need to do something like that, but using our pure dependency injection setup. I have an idea. Let's go to the composition root file and create this inject method. This is an inject method, and we said that we pass this. So what is this? This is a main activity. All right, then we can pass an activity, main activity. So if we were to go here and go my application.compositionroot.this, well, this would compile, and this looks very good. So what we have to do now, we have to add functionality in this inject method. Our presenter currently is private. We have to change that and keep it public so that this inject method can inject the presenter itself. So if we go back here and go activity.presenter and use the get main presenter, which we're going to pass activity to, look at that now. We can go and get main presenter, it can get private. So this looks good. Every object that we need gets created here, and inject is the only public method that the main activity will use. So we can delete that. And would you look at that? This looks pretty good. We have injected the presenter. Then the presenter gets its arguments and its dependencies from the outside. And finally, once again, the interactor as well. This looks good. So let's just go ahead and run it. I've exited the presentation mode so that I had to edit that video right there, but I just pressed play. So we're building currently, waiting for the application to run again, so we can see that we did not break any functionality, that the button still clicks, the loader shows up, and finally we get the list of results. Gradle is running again, and of course, even for the simple application, we have to wait. Okay, so invocation was finished, and what do we got here? All right, this looks good. Let's press the button, the spinner is there, and our list of strings shows right back up. So we did not break anything. We effectively refactored our application to use dependency injection, and everything looks so much better. But I want to add one more thing here. So what I wanted to show you is this. I still don't like this syntax right here. So what I like to do is create a base activity that every activity I create extends. So I'm going to ask Android Studio to create this class for me into a separate file. Yes. And this abstract base activity obviously extends upcompat activity. So this compiles, and let's optimize our imports. And then we can create a val composition root. This is a composition root that we get from the application class that is casted as my application dot my composition root. So now what I can do, actually let's do this let's mark this as protected. And here, instead of doing all that, I can simply call composition root. That's the new name. So this looks better. Look how clean that is. This shows that I inject myself, it's clear. It resembles popular frameworks such as Dagger and does the same job. Another way to perform the injection, instead of having a different function for every activity, is to have a single inject function that simply takes a generic activity inside, and then we would use annotation. So every field that we would need to be injected, we could annotate it, and then inside here, we can go through the annotations and inject the fields that we need to be injected. I'm not going to do that here because it's not needed in too much work, because the concept still applies. I just wanted to show you that it's entirely possible to have a composition root, a composition container, without using any framework. Here we simply create our objects, we wrap them together in an inject function. Here we would have multiple things in an activity, and we would simply have the function that would create that dependency, and everything would look good. And in our activity, all we would have to do is mark our properties as public, so that the inject method has access to it and visibility, and we would be set to go. We would not need to create anything. So when the time comes and we need to replace this presenter with instead of getting my main presenter implementation, we would have to replace it with main presenter implementation, let's say 2. Then all we would have to do is simply change this function here, and our code would continue to work. That's the power of dependency injection. Okay, what do you think? This was a long video, so I would suggest you watch it more than once and maybe try to think of the change that you would make to the code before I do it. We said that dependency injection is the separation of classes into 2 separate sets, and we did just that. We used the composition root class that we created inside my application, which is the entry point for an Android application, to create and connect dependencies. Then, through that application class, we passed those created objects to our functional set. And this wraps our dependency injection mini-series. I would be happy to answer any questions or hear your feedback in the links in my channel. My name is Konstantinos. Thank you very much for watching, and I will catch you on the next video pretty soon. Bye.